Hello, my shimmering stars. Today, I, Shaurya Grover, welcome you all to this amazing platform of PW English. So, students, today I am here before you in our Nexus batch, and we are going to start with our lecture number 6. Now, what are we going to cover today? We are going to cover the most important topic of ours with regard to the chapter classification of elements and periodic properties. So students, today we are going to understand in depth about electron affinity or electron gain enthalpy. Now many of the students do have a doubt in this particular segment. Are they same or they are different, or what exactly is the scenario? So one by one we are going to understand first of all that what is electron affinity, and then we will be focusing on the topic that is variation along the period and the group. Yes. So now we are going to start with the very first part. As you remember in the previous session, we were discussing about electronegativity, we were discussing about ionization enthalpy. So I will give you a quick recap of what we have done so that we can focus upon this one. Because see students, these all the periodic properties, atomic radii, ionization enthalpy, electronegativity, then we have this affinity one, electron gain enthalpy or electron affinity one. All of these have various trends, various variations across the period and along the group. So many a times what happen, you know the criteria, but you just mix all of them all together. So that's why I'm doing a quick recap first of all in 10 to 15 minutes, and then we will be proceeding to our today's topic, the major important segment. So as you all know, this is going to be our lecture number 6, my dear students. Yes. So how we are going to proceed in our batch? First of all, I will be explaining you regarding the trends along the period and the group for ionization enthalpy, and then for electronegativity. We are going to revise it, in the initial segment. Then we will be understanding about electron affinity or electron gain enthalpy, and then the variation segment of that as well. So let us proceed with the very first part, but before that, let us meet your friends. So they are inviting you again, they are welcoming you again in our session today. Yeah. So basically your friend says, hello shimmering stars. Okay, have you revised yesterday's class? If not, then we are going to revise first and then we are going to proceed further. So basically barium and calcium are there to help you out throughout your session along with me. Yes. So barium says, hi friends, be ready for the topic trends or variations. See students, so many questions in the previous year examinations are being asked from the trends and variation segment. Because see, here we are going to apply all the concept that we have studied till now. Either it is of atomic radii, either it is of nuclear charge, or it is of electronic configuration, or penetration effect, or screening effect. So we are going to apply all the concept in the variation segment, and this helps us a lot. Yes. So let us first of all start with variation of ionization enthalpy. Now, what is an ionization enthalpy? You very well know. When you have to remove an electron, so the energy provided in order to remove the electron from the outermost shell of isolated gaseous atom, that is basically ionization enthalpy. Yes, so the removal of an electron from the outermost shell, that is basically the energy given in order to do that is ionization enthalpy. So students, coming to my segment over here, if I'll talk about on which factors does it depends. So the factors on which ionization enthalpy will depend, basically what are the factors? So the initial factor, if I'll talk about, initial factor that I'm going to talk about is going to be the size. The second factor that I'll talk about will be about nuclear charge. Then the third factor that I am going to discuss about is going to be the electronic configuration. The fourth factor that we shall be talking about will be your screening effect or the penetration effect that we do study. Yeah. So these are some factors that are responsible for the ionization enthalpy trend. And if you remember students, if I talk in general, if I am taking in general, let us consider in general, what happens across the period and along the group. So in general, across the period, if I'll talk about, that means if I am moving from, that means if I am moving from left to the right direction, if I am moving from left direction to the right direction, what happens to my factors? The initial factor, nuclear charge, basically will increase when we are moving from left to right. What will happen, ma'am? Nuclear charge while moving from left to right increases. This is a symbol of increase. Now nuclear charge in other terms is number of protons, right? See, in a particular period, the period number remains same, the shell number remains same. So nuclear charge will increase. That means protons are increasing, right? If nuclear charge is increasing, what is nuclear charge? Now I guess you all are very well aware of the term nuclear charge, because in so many segments now we have already discussed again and again the topic nuclear charge. So see, for example, the charge exhibited by the nucleus on the outermost shell valence electron, that means the electrostatic force of attraction that we used to see between the nucleus and the outermost shell electron, is basically the nuclear charge. Charge by nucleus, charge exhibited by nucleus. Yeah, so basically this is what it increases as we move, because number of protons increases. Nuclear charge, that means charge of nucleus. Now nucleus basically depends upon neutrons and protons. So neutrons are neutral in nature, that means it depends upon the protons. So as you will see, a longer period, number of protons increases, that means nuclear charge increases. If nuclear charge increases, electron, it is attracting electron. Let us consider this is nucleus, this is electron. If it is attracting, it is coming closer to the nucleus, so the size is decreasing. See, size is decreasing. What actually is size? Size is basically the distance from the centermost position to the outermost valence shell. So that distance is atomic radii, or the size, I would say, no? So when electron is coming inside towards the nucleus, the size decreases. Hence, what we say over here, ma'am? That, ma'am, size decreases. This is the general trend. If size decreases, students, ionization enthalpy should increase. What should happen to ionization enthalpy? It should increase, everybody. Yeah, this is in general, I'm writing in general. Now let us see along the group in general. So when you are moving from top, to bottom, what happens over here? Ma'am, when you are moving from top to bottom, number of shells increases. Number of shells increases. And as shells increases, size will also increase. Size will also increase. And if size is increasing, ionization energy or enthalpy will decrease. It will decrease. Why? Because see, the very first factor that we were discussing it over here is about size. Always remember, ionization enthalpy or energy is inversely proportional to size. If you are going to increase size, ionization enthalpy will decrease. Let us talk about nuclear charge. So ionization enthalpy is directly proportional to nuclear charge. Okay, if you will talk about electronic configuration, fully filled will have the highest electronic configuration, then the half filled one, and at last it will be the partial ones. They will have the highest value because it is stable, and you are removing electron from the stable electronic configuration, so you require a lot of energy. So fully filled will have the highest, then comes the half filled, and at last the partially filled one. At last the partially filled ones. And if I'll talk about the screening effect, S has the highest, then it's P, then it's D, then it's F. Clear, students? And one more thing, do remember, if it is poor shielding, that means inner electrons cannot protect the outermost electron to come inside. That means outermost will come inside, size will decrease, and ionization energy will increase. Yes. Next, if it is good shielding, If it is good shielding, then size will increase, because if it is good shielding, repulsion will occur, it will repel the outermost electron, it will go apart, size will increase, ionization enthalpy will decrease, right? This is in general, students. So when you are writing across the period, you observe certain changes due to this third factor. Fully filled will have the highest one, then it will be the half and the partially filled ones. That means you have seen in the case of beryllium, it will have more than boron. You have seen in the case of nitrogen, it will have more than, the oxygen one, right? So basically they will increase one in front. Yeah. And yes, neon will have the highest one if you remember the period number 2. If not, students, you can go and see the previous session. You will get this basically criteria. So this is the criteria for the variation of ionization enthalpy. Ionization enthalpy. Again repeating, this is in general, but when you are going to write in period number 2 and 3, you are going to see the exception as per the rule number 3rd, which I have already explained you in the previous class. So I guess this is now quite, everybody has revised it properly. Yes. Now students, we are going to start with the next one variation segment, that is of electronegativity. So first of all, let us discuss in detail about electronegativity. In the previous session also, when I was when I was discussing with regard to atomic radii, I told you that yes, when we do have a different atoms and they are covalently bonded with each other, they will have electronegativity difference between each other, right? And due to that, they will develop some charges on them due to the difference in electronegativity. So what actually is electronegativity? Electronegativity is tendency to attract shared pair of electrons towards itself. Okay. For example, if I am electronegative in nature, I will attract negative, lone pair of electron towards me, the shared pair of electrons towards me. So that is what is electronegativity. Now electronegativity is sharing of electrons, not donating electrons. It is sharing, right? So when it now this for electronegativity also, let me write the general trend. Let us write the general trend for electronegativity also. Yeah. So in general, first of all, let me write on what factors does it depends, so that you won't get confused. The factors on which electronegativity depends is number first, again size. Number second, its nuclear charge. And number third basically is electronegativity is directly proportional to the positive charge and to the negative ones. Yeah, so basically see students over here, if I'll talk about the size factor, yet again electronegativity is inversely proportional to size. Okay, inversely proportional to size. If you're increasing size, electronegativity will decrease. If I'm talking about nuclear charge, so electronegativity is directly proportional to nuclear charge. It is directly proportional to nuclear charge. So these are the factors on which electronegativity depend. Electronegativity don't depend upon the electronic configuration. Coming back to in general, if I'll talk across a period or along a group, that means this is from left hand side to the right hand side in period, and this is from top to bottom. Yes, everyone. So now see. So in this case, in general, left to right, if I'll talk about, what will happen, ma'am? Nuclear charge will increase, so size will decrease, and we know electronegativity is direct inversely proportional to size, so electronegativity will increase. Similarly, in the case of top to bottom, we see that number of shells increases, so size basically will increase, and electronegativity is inversely proportional to size, so electronegativity will decrease. Clear, everybody? Please write it down so that I can move on to the next part. Everybody, please write it down so that I can move on to the next part if it is done. Done? Yeah. This is the in general trend. Again, one thing I have missed over here with regard to ionization energy, let me tell you. For the boron family also, we obtained this kind of graph. Yeah, so do remember that as well. boron, aluminium, gallium, indium, and thallium. This was with regard to ionization enthalpy for the P blocks one. See, for the second period and third period, I told you third factor is responsible. For the group one boron family, this is responsible. Electronegativity, I've already told you this is also in general, it depends upon the size only. And yes, we can calculate electronegativity through three scales, Millikan, Pauling, and so on, right? So, among which Pauling scale is the most appropriate, which is considered mode. Okay. Now let us read from NCRT. What are the NCRT highlights for the electronegativity? If I'll talk about over here. One more thing, which is the most electronegative element among the whole periodic table? So let me tell you students, electronegativity is sharing of electrons, right? If I'll talk about inert gases, they won't share any electron because they are stable. For them, it will be zero. That means most electronegative atom is going to be fluorine. So do remember, in electronegativity, most electronegative element among the whole periodic table is going to be your fluorine. Clear? Now let us read from NCRT. A qualitative measure of the ability of an atom in a chemical compound to attract shared electrons to itself is called electronegativity. Unlike ionization enthalpy and electron gain enthalpy, it is not a measurable quantity. Yes. However, a number of numerical scales, which I already told you, Millikan and Pauling, okay, are already explained you that are already there, that is basically in order to calculate electronegativity. So that is Pauling scale, that is Mulliken-Jaffe scale, and Eldred-Roschow scale. They have been developed, okay, among which Pauling is the one which is used more commonly. Now, electronegativity generally increases across a period from left to right, if you will see. Why? Because size decreases. Yeah, say from lithium to fluorine, and decreases down a group from fluorine to astatine. Across a group, it decreases, right? Because size increases. So fluorine is the most electronegative element. So this is again yet most important key point from the NCRT that you should know. Clear everyone? Everybody please write it down so that I can start with my next segment, that is electron gain enthalpy. Clear? Variations I have already told you students. Now we are going to start with the topic electron affinity. What is electron affinity? First understand this key concept. See, electron affinity, for example, this is your nucleus, right? This is your nucleus. This is your first shell. This is your second shell. This is your third shell. Let us consider I have to add one electron from the outermost shell, right? So when I'm adding this one electron in the outermost shell, the energy released on addition of an electron into outermost shell of isolated gaseous atom is basically called what? Is basically called electron affinity. Repeating again, what is electron affinity? The energy released when you are entering one electron into the outermost valence shell. So that energy released is electron affinity. Now many of the students will say, ma'am, what is then electron gain enthalpy? It is also addition of electron. Yeah, but what is electron gain enthalpy? Electron gain words itself says you are gaining electron, right? So electron gain enthalpy is energy provided to electron so that it can enter the outermost valence shell, right? That is basically when an electron is added, energy released. That is electron affinity. But this is something when you are providing energy to electron so that it can enter. That is electron gain enthalpy. Clear, everyone? Now see. Also one more thing. Electron gain enthalpy is negative of electron affinity. If it is positive, it will be negative. If it is negative, it will be positive. Clear? Let us read it. It is, now I am explaining electron affinity. It is defined as change in standard molar enthalpy when a neutral gaseous atom gains an electron to form an anion. What is an anion? The one which carries a negative charge. See, for example, if we have X. Now, if it is gaining one electron, it will gather which charge? Negative charge. For example, if I am a neutral species, I have equal positive and negative. If I am getting one more negative, so negative will become more, so I will get a negative charge. Clear, everyone? So this is electron affinity. When an electron is added to the atom and energy is released, the electron gain enthalpy is negative. And when energy is needed to add an electron, the electron gain enthalpy is positive. Clear? Clear, everybody? Now students, coming to the variations. Now on what factors does electron affinity depend? First of all, let us discuss the factors. Let us discuss the factors on which it depends. So the very first factor among them is going to be the size. See, when I'm talking with regard to size, so electron affinity is inversely proportional to size. If size will increase, electron affinity will decrease. See, for example, we have to basically add one electron into the outermost shell, right? So when the size is small, you are adding one electron. Other electrons will do repulsion now. This is what basically it is. Other electrons will do repulsion now, no? So when other electrons are doing repulsion, so that it cannot be added, right? In the small atom, for example, if you are large atom and if electron comes into the outermost shell, there will be not much as repulsion because from nucleus to the outermost shell distance is more, so it won't affect it more. It can easily enter. But in the case of smaller atom, if electron is entering, it has to face the repulsive forces also. So that means over there, in that case, in small atom, you have to provide a lot of electron affinity. A lot of energy will be released. Also, you have to give a lot of electron gain enthalpy so that the electron can enter into it, because size is small, repulsion will be more. That's why. So electron affinity is inversely proportional to size. Next is nuclear charge. So in the case of nuclear charge, electron affinity is directly proportional to nuclear charge. Directly proportional to nuclear charge. If more number of protons will be there, it will attract that electron more. If less number of protons are there, it won't attract as much as more number of protons. Positive and negative attract each other. That's why. The next factor is electronic configuration. See, electronic configuration over here is that if I'm discussing about fully filled, it already has fully filled electrons. For example, if I'm talking about p orbital, let us consider it is completely filled. So now you have to add one electron. Where you will add? There you won't be able to add an electron. That means for fully filled it will be 0. That means for half filled, as half filled is stable. So if you're adding electron, you will make it unstable. It will become unstable after an addition of electron. It will become unstable, right? Also in fully filled, already electrons are there. So how will you add? So it is also 0. That means now electronic configuration for half filled, fully filled is 0. But in the case of ionization enthalpy, they do have some values. It was highest for fully filled, half filled. But for them, it is 0. Let us consider the variation trends now. Let us start in the period number 2. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. See students, now what happens when we move from left to right, when we move from left to right, we have seen in general that ma'am nuclear charge, increases because number of protons are increasing. That means ma'am size basically is going to decrease because nuclear charge and size are inversely proportional. Nuclear charge is increasing, electron is coming inside, size will decrease. So what will happen to electron affinity? Ma'am, it will increase because they are inversely proportional. It is directly proportional to nuclear charge, so it will increase. That means this should be our trend. But let me tell you students, it is incorrect. What will be the correct one now? Let us see. Let us see what will be the correct one. It is lithium. See here we know neon is fully filled electronic configuration. Let us write the electronic configurations. See, lithium atomic number is 3, beryllium is 4, 5, 6, 7, 8, 9 and 10. So if I have to write, it is 1s2, 2s1. It is 1s2, 2s2. It is 1s2, 2s2, 2p1. It is 1s2, 2s2, 2p2. It is 1s2, 2s2, 2p3. It is 1s2, 2s2, 2p4. It is 1s2, 2s2, 2p5 and it is 1s2, 2s2, 2p6. See, p6 that means it is fully filled. See, in the case of nitrogen, it is p3 like this 1, 1 and 1. So it is half filled. While in the case of beryllium, it is 2s2. So it is also fully filled. So I told you fully filled will have 0 value. That means least value will be of neon. Also beryllium is also fully filled. So it will also have least value. Then it will be half filled, that is nitrogen. And after that the trend remains same. What it will be? Lithium, boron, carbon, oxygen, fluorine. But still it is correct. Still it is incorrect. Then ma'am what will happen? See. Let us write the configuration for lithium and boron. See, lithium is 1s2, 2s1, right? If I'll talk about boron, 1s2, 2s2, 2p1. So in electron affinity, you are adding one electron. If you'll add one electron into it, it will be stable. It will become 2s2 stable one. That means if you'll add one to this won't become stable, but it is stable. 2s2 is stable. So if it is stable, so it will have more value than boron, right? So the answer is going to be neon, then beryllium, then nitrogen, then boron, then lithium, then carbon, then oxygen, and at last fluorine. So fluorine will have the highest value among them in this period. Clear everybody with the period number 2. Clear everybody with the period number 2. I'll revise all over here again. See, when you are moving across a period, nuclear charge increases, size decreases, ionization, enthalpy, electronegativity, electron affinity will increase. So this should be the trend. But I've already told you right now, electron affinity for all of the species, like for half filled and fully filled is going to be 0. Why electron affinity? Because they are stable. They don't require any electron. Fully filled don't require any electron. They are already filled. Half filled is stable. If you give one electron, it will become unstable. For them, it is 0. That means neon will be 0. Then it will be beryllium because it is 1s2, 2s2. 2s2 is filled. Then comes nitrogen, half filled. Then the same order. Lithium, boron, carbon, oxygen, fluorine. But you are adding one electron. This is the order for electron affinity. You are adding one electron. So if you add one electron into the lithium, it will become what? 2s2. It will become stable. So it will have more energy than boron. So this is going to be the order. Everybody write down so that I can move on to the group section. Done. Now let us see for the group part. Across the group. That means ma'am, top to bottom. That means ma'am, top to bottom. If you are moving from top to bottom, see students, what will happen? Number of shells increases. If shells are increases, size will increase. And size and electron affinity are inversely proportional, so electron affinity will decrease. But let us see this in the case of, for example, if I'm talking about group number 1, it is hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Yes. So when you are moving from top to bottom, number of shells are increasing, ma'am. And size basically will also increase. If size will increase, electron affinity will decrease. So if it will decrease, this is going to be the order. Yes, this is going to be the order. But this is for group number 2. Now comes an exception case. What is the exception? Let us talk about your group number 17 first. Fluorine, chlorine, bromine, iodine. See, in these cases, what will happen? I've already told you, when you are moving from top to bottom, number of shells, let us consider, they are increasing. So size basically is increasing. Electron affinity will decrease. So that means this should be the order, but this is incorrect. Chlorine will have the highest one. Second element will have the highest one over here, because see, in these cases there will be electronic repulsion that takes place, and due to the anomalous behavior of fluorine as well, chlorine will have highest due to electronic repulsion among them, and hence it will have the highest value. So it will be chlorine, fluorine, bromine, and then iodine. This will be the order. Also, students, I told you that across a period this is going to increase because size decreases. If it will increase, that means chlorine is the element which has highest electron affinity, and fluorine is the one which has highest electronegativity. Now same trends occurs in all of the cases, but yes, in oxygen family it is quite different, so I am writing for them as well over here. See, let us write group number 13: boron, aluminium, gallium, indium, and thallium. I am writing for group number 13th. For 14th, you have to write in the homework segment the trend. Then I am writing, then you have to write for group 15 also in the homework. I will be writing for group number 16. Let me tell you, these are same as group number 17. Both of them are same as group number 17. But for group number 16 also it is different. Oxygen, sulfur, selenium, tellurium, and polonium. So for them the values are different. So let me tell you. Now this is also again similar to the previous one. Aluminium will have the highest one. Rest the order will remain same. For electron affinity. Now for this one, let me tell you. As I've told you, see, sulfur will have the highest one, no? Oxygen will come at the second number. But over here, it is different. This is not the order. This is yet again incorrect. Oxygen will have the least value, not the second value, but the least value. So sulfur, selenium, tellurium, polonium, and at last it will be oxygen. But for all of the other groups, the trend is same, that the first element will have less than the second element. But for that, the trend will be remaining different. Clear? So this is the correct one. Everybody write it down. Everybody write it down so that we can read the NCERT highlight as well. Let us read the NCERT highlight as well. So now comes NCERT highlight. When an electron is added to a neutral gaseous atom to convert it into a negative ion. See, you are basically adding an electron. And addition of an electron produces an anion. Yeah, because something will get a negative charge. Okay, the enthalpy change accompanying the process is electron gain enthalpy. The electron gain enthalpy provides a measure of the ease with which an atom adds an electron to form anion. Now, depending upon the element, the process of adding of an electron to the atom can be either endothermic or exothermic. For many elements, energy is released when an electron is added to the atom, and the electron gain enthalpy is negative. Energy will release at that spot of time, that is electron affinity. Yeah, clear everybody? So this is NCERT highlight for that as well. This is NCERT highlight. Now let me summarize all the factors on a single sheet. All the factors. In general, across the period, what happens? That means from left to right, what happens? From left to right, ma'am. From left to right, ma'am, it's a very simple thing that nuclear charge increases. So the very first factor, size or the atomic radii, it will decrease. Clear? Second was ionization enthalpy. Ionization enthalpy is inversely proportional to size, directly proportional to nuclear charge, so it will increase. About electronegativity, it will increase. About electron gain enthalpy, it will increase. Clear? Now from top to bottom, this I am writing in general, students, so don't get confused. From top to bottom, number of shells increases, so size, or I would say atomic radii, size or atomic radius basically will increase. If shells are increasing, size or atomic radii will increase. So ionization enthalpy will decrease because it is inversely proportional. Electronegativity will decrease. Electron affinity will decrease. Clear, everyone? So this is in general the trend. In general the trend, everybody. This is in general the trend. Clear, everyone? Yes. Now comes your homework part for today's class. Solve NCERT all in-text questions. Solve NCERT all in-text questions. Clear, everybody? All NCERT in-text questions. And second part, read and mark all NCERT highlights given to you on the sessions. Clear? Third part, write all the variations along with exceptions for atomic radii, ionization enthalpy, electronegativity, electron affinity, across a period and along the group. Everybody, please write it down, whatsoever homework which I have provided you over here. Everybody, please write this down. This is the homework section that you have to do. The very first is solve NCERT all in-text questions. Second is read and mark all NCERT highlights. Third is write all variations along with exceptions for atomic radius, ionization enthalpy, electronegativity, electron gain enthalpy, or electron affinity. Clear everybody on a sheet of paper across a period and along a group. Now students, we are ending our today's class over here. In tomorrow's class, we will be ending this chapter. Now we are only left with the trends in the chemical properties and the question part. So I've seen many of the students are writing for questions, more questions. So what we are going to do in the last segment, first of all, we will be solving the homework questions of all the sessions that we have done till now. And after that, we will be solving the previous year questions based upon this chapter, that is classification of elements and periodic properties. So first we will cover our topic, that is chemical properties, trends in chemical properties. Then it will be homework section. Then it will be question round. So everybody, please do revise all the complete chapter by today. Complete till this topic so that you can cover the last topic and solve the questions. Because if you have not revised the topic, you won't be able to solve the questions. So revise the topic, create the chart of the variations of the period and the group, and we shall be meeting in the next class with so many questions from the previous year papers, right? So thank you so much, my dear students. Till then, keep smiling, keep learning. Thank you so much and take care. Thank you, everybody.